Fortnite is cartoon Pugba.
I don't know what that is.
Okay. Pubga.
They're both on mobile now.
Yes, I know. Yes.
I feel more active.
Fair enough. Okay, guys. Raise your hand if you got a number smaller than 1. Uh-oh. Okay, maybe I should ask that again in 10 seconds.
So I was
8. Yeah.
Okay, raise your hand if you got that. If you got a number less than 1. Good. Did you get 0.45?
Yeah. I don't need to write anything down.
You totally do.
You really should.
Next, what is the concentration of a solution of 87 ions in 2.4 times 10 to the negative 23rd liters of water? It's a tiny amount of water. So again, same thing. Find out how many moles you have, then divide that over the volume, and you'll have your concentration.
Mole signs is a 1-to-2 ratio, right?
Say again?
Is the moles to ions a 1-to-2 ratio?
No, 6 times 10 to the 23rd. So there's 6 times 10 to the 23rd ions in moles. Oh, as far as like turning a concentration into an ion, that depends on what your concentration is originally, and we will do that actually.
Yeah.
Okay, so you have 87 ions, and there's 6 times 10 to the 23rd ions in 1 mole. So then once you have the mole, it just becomes another simple mole over liter calculation. Your number is going to be larger than 1.
Oh, that's fine. Yeah, actually.
Literally just gives me 8.78.
And not this wrong.
You're wrong.
Don't fight. In life, someone's going to be right, someone's going to be wrong. You don't need to fight about it. Okay, so I take it from the chat. Are you ready to go?
Yeah.
If you got a number larger than 1, raise your hand. Larger than 4?
Yes.
Larger than 5?
Yes.
Larger than 12?
No.
Okay, 6?
Yes.
Okay. Now, back to what we were talking about originally. How many ions dissociate for every mercury 2 bromine molecule? Write out the dissociation equation for mercury 2 bromide. No, it doesn't. Because they're ions. It's not breaking down into a diatomic gas. It's breaking down to 2 Br ions. Ions don't have to be diatomic. 2 Br. 2 Br. So hug Br 2 goes to 1 hug plus 2 Brs. Okay. So mercury 2 bromide, HDPr2, solid, is going to dissociate into a mercury 2 plus ion and 2 bromine minus 1 ions. Okay. So how many ions dissociate for every mercury 2 bromide? 3. So next question. Because there's 1 mercury and 2 bromines. Oh, right there. Okay. Thank you. because the mercury bromide breaks down into 1 mercury and 2 bromines.
So you always write it like that?
Yes, please. Okay, next. What are the 2 concentrations? I'm not going to do this for you. This is for all you. What are the 2 concentrations you get when you have 14 ions of mercury and 28 ions of bromine in 1 times 10 to the negative 16 liters of water? This is going to be very similar to the simulation you're going to be doing tomorrow. That would be best. Yes.
So I put that in. I got that answer. I divided it
You do 87 or 8.7?
8.7.
It's 87.
It's 87.
Yeah. That's why you, okay. But anyway, so you got that answer. You got 1.45 times 10 to the negative 23. Good. And you divided 1.43 times 10 to the negative 23. Oh, you forgot the 2 times 10 to the negative 23. You just divided it by 24. Right, but that exponent needs to be in the denominator, not on the numerator.
That's how I entered it when I did it, and I even did it in parentheses, but then it just goes to that.
Let's do it together. 1.45. Down, okay. Down. 1.45 e key negative 23 divided by 2.4 e key negative 23. Enter. And again, it's off by 0.6 because you did 8.7 instead of 87. So 14 divided by 6 times 10 to the 23rd gives you the moles of mercury. 28 divided by 6 times 10 to the 23rd gives you the moles of bromine. Those moles divided by your volume of 1.0 times 10 to the negative 16 is going to give you these concentrations. And it should make sense that the concentration of the bromine is exactly twice the concentration of the mercury, because there's twice. Okay. If this is rolling around in your head and making sense to you and you're not using your phone as a toy, give me a thumbs up. Okay. Then I have a question for you. What is the concentration of the entire molecule? Which one of these 2 is the concentration of the entire molecule? The smaller one. Yeah, because there's a 1-to-1 ratio between the mercury bromide and the mercury. So this is the concentration of the mercury. It's also the concentration of the molecule. Does that idea make sense? Question? Sure. So what you need to do is you're going to take your 14 ions of mercury, and you're going to figure out how many moles that is. There's going to be 6 times 10 to the 23rd ions in 1 mole. Once you have that mole, then you're going to set the molarity equal to mole over, in this case, 1.6, 1.0. 1.0 times 10 to the negative 16 liters. That's going to give you your molarity. I realize you guys don't like using big and small numbers, but that's kind of have to in the simulation. Okay. Other questions? With the remaining 11 minutes, off we go. Give me a thumbs up if you're ready to learn something new and easy. Sure. New and easy coming up. Okay. We're going to skip solution preparation, talk about it next week. Colligative properties. Colligative means depends upon amount. So a colligative property depends upon the amount of stuff you have. In other words, the more you have, the bigger your property. So if you know what's going on in your car, there's coolant that runs from your radiator through little channels in your engine block to keep your engine block from melting down. Unless your pump's broken, in which case hopefully your engine's going to shut off. So the water pump pumps coolant through your engine block, through the radiator. It picks up heat from the engine block, and it gives it off at the radiator. And then it goes through again. Cooler water goes to the engine, goes back to the radiator, cools down, and so on. Okay? Now, we add something to the water. We add ethylene glycol or propylene glycol to the water. Why do we need to add it to the water? Exactly. So the water doesn't get so hot and boil off and evaporate. Well, we do that because the ethylene glycol gets in the way of the water molecules. Okay? The water molecules want to boil off. The ethylene glycol gets in the way. That drives off the boiling temperature of water, drives it up to the point where it hopefully won't boil off. Okay? That's a colligative property. It can change the physical properties of a solution by getting in the way. So it lowers the freezing point and increases the boiling point. If we were in Michigan, we wouldn't call it coolant, we would call it antifreeze. Because you don't want to show up in the morning, start your car, and have a block of water in your radiator, and then there's nothing for the pump to turn. So you don't want that coolant to freeze. We call it coolant because we live in the desert. If we lived up in Canada, they'd call it antifreeze. But that's a colligative property. The more stuff you have, the more the freezing point gets driven down, and the boiling point gets driven up. Now, that's the equation, that's the formula for colligative properties. We're actually not going to calculate colligative properties. If you want to do it, you can do it in Chemistry AP next year. You just need to know what colligative properties are and how they work. Some of you are still scribbling, some of you are good. Any questions about this? All right. Give me a thumbs up if you're ready to learn the last thing. All right. Last thing, osmosis. I think it's the last thing. Oh, no, second to last. There's one more thing we need to talk about after osmosis. Osmosis. Raise your hand if you remember hearing the word osmosis in biology. Keep your hand up if you still remember what it is. Oh, that's cool. So, America, what is it? Awesome. Well done. Yeah. So, osmosis is the travel of a solvent from an area of low concentration to an area of high concentration, or from an area of high purity to low purity. Okay. From an area of clean to dirty. The fish in the sea? Oh, okay. My favorite example is pickles. Well, what's a pickle? Yeah, it's a cucumber that's been allowed to hang out in a bunch of brine. Brine is a solution of salt water. Sometimes they put vinegar in there too. And what happens is the cucumber represents the high purity, and the brine solution represents the low purity. And the water goes through the membrane of the pickle into the dirty water, into the dirty brine. So it shrivels up. That's osmosis. Something we used to do when I was in high school that nobody does anymore here, which is too bad. One of these days, I'm just going to bring it in and let you guys do it for fun, is we used to put red blood cells in pure water and in salt water. If you put a red blood cell, so it makes your blood red. If you put a red blood cell in pure water, the pure water will go into the red blood cell from high purity to low purity, from clean to dirty. And then the red blood cell will swell up kind of like a football and then eventually burst. Yeah, it's pretty cool. You can see it happening. Yeah, well, YouTube is a reasonable substitute because it happens a lot faster in YouTube. In the same thing, if you take the same red blood cell and you put it in a brine solution, a concentrated saltwater solution, the red blood cell will be the high purity and the brine will be the low purity, so the water will leave the red blood cell and the red blood cell will shrivel up like a raisin. That's also why your nurses, when they hang an IV, they don't hang pure water. They hang a saltwater solution. So they call it saline. They're hanging a saline solution if you need fluids. I'm going to take your word for it on that one. So again, a cucumber is made by a pickle is made by placing a cucumber in concentrated brine solution. Also fun, you can put limp carrots or celery in water, and the water will go into the celery and carrots. That's kind of cool. Okay, give me a thumbs up if you're ready for the last thing. All right. I asked you, no, a quick question. It depends on what you're talking about. It's high purity to low purity, and it's low concentration to high concentration. It's from clean to dirty. Okay, so give me a thumbs up if you're ready to move on. Cool. I asked you in the lab yesterday to research the difference between a strong electrolyte and a weak electrolyte. What is the difference? You can show me your hands, so you can volunteer your answer. What is the difference between a strong electrolyte and a weak electrolyte? True, but what makes something strong versus what makes something weak? Exactly. A strong electrolyte disassociates completely into its ions. A weak electrolyte disassociates only partially. So a strong electrolyte has a lot more ions than a weak electrolyte. For a strong electrolyte, you dump in 1 billion molecules, you get 2 billion ions. For a weak electrolyte, you dump in 1 billion molecules, you only get 2,000 ions. Make sense? Understand the difference? Okay, and that's where we're going to end. If you're not going to be here tomorrow or Friday, actually tomorrow, because if you're going to be here tomorrow, you'll get the lab. Start a line here, starting going this way. This is page 1, page 2 of your lab, and staplers are over there. So if you're a bandage and you need to do the lab on the bus, then start a line over there and move this direction.